Okay, so welcome back. So this is the last lecture. I already recorded this video 2 times, but due to some problem, this was not recorded. Okay, so let's start this 3 time. So we are going to talk about the DRAMs, dynamic RAMs. Okay, so this is similar to the SRAM. They stored 1 bit each. Okay, the similarity is this that they stored 1 bit each cell. If we talk about, so once each cell of the DRAM stored 1 bit, one cell of the SRAM stored 1 bit. But the primary difference between the two is that DRAM using a single transistor and a capacitor to store the bits. And as you might be remembering that the SRAM stores a bit on a latch. So you can see that normally the SRAMs are 6 transistor, 8 transistor, like this number of transistors are required, and here we required only 1 transistor and the 1 capacitor. So we can say that the size of the cell of the DRAM is very small, and the if you talk about the chip area, so if you want to fabricate on a chip, so in the same amount of area, large number of DRAM bits can be stored. So means the packing density of DRAM is higher than the packing density of SRAM. But there is a little problem in DRAMs that we need an additional circuitry at times because the charge is stored in the capacitor. This at times we need to refresh this. Okay, so if the charge in the capacitor is 1, the capacitor is fully charged, means the 1 is stored. If the capacitor is discharged, means the 0 is stored. Okay, so what happens, automatically some charge starts leaking out, and this causes this voltage level to reduce, and hence we need to provide the refreshing circuitry. Okay, so we'll see the all the operations of the DRAM. Before this, just a quick reminder of the how the transistor works as a switch. You may be remembering. Just a quick reminder from my side. If the transistor is like this, okay, so if we apply a gate signal VGS, are you remembering? If this VGS is greater than VT, so what happens? This transistor connects these two signals. These two lines will be connected. Okay, so the source will be connected to the drain, you can see. Okay, so these two will be connected and the current will be flowing. The current will be flowing. Okay, so this is in the high state, and if in the this reverse is true, so what will happen? These two will not be. Okay, we apply a VGS signal which is less than VT, so these two will be off and the switch will be like in this state, so the switch will be off. So the transistor is acting as a switch, it is connecting and disconnecting the two terminals. Okay, so this is how transistor acts as a switch. A quick reminder. So what we have, if we want to turn on this transistor, we have to apply a high signal on the gate. Okay, so the gate is high signal is called the row signal. Okay, so if we apply high, so we have to apply high here to turn this transistor on. Another thing is that whenever we want to access this capacitor, means we want to read or write or refresh, we have to turn on this MOS. Okay, so MOS is on. Now this can be connected to this point. Okay, so it depends what we want to do. So the it will charge or discharge. It depends on, or what is the operation will be happen. It depends on the voltage what we are going to do. Okay, so the first thing that we are going to do is the writing of 1 into the memory. So you can see the we want to write 1, means we want to store a charge on the capacitor. Okay, so the stored capacitor is a 1 and the discharge capacitor is a 0. Okay, so what we have, there is a signal, this signal is here, and this is the read write signal, read slash write bar equals to 0. Okay, if we make the signal to 0, so what will happen? It means the read r equals to 0 and w bar equals to 0. it means read equals to 0, it means we are not performing the read operation, and W bar equals to 0, which translates to W equal to 1, and this means we are going to perform a write operation. So there are three buffers. This is called the refresh buffer, the output buffer, and this third one is the input buffer. Buffer is here the buffers are the tri-state buffers, means if they are enabled, so they can be high state or the low state depending on के input इसमें क्या हमने apply किया है, and they can be also the tri-state, means the impedance state, means they are not in any high or low state, they are in the high impedance state, they will not give any output. Okay, so it means they will be like high impedance, nothing is there. Okay, so these three are the buffers. So we can enable by buffer by these signals. If the input this signal is connecting to the buffer is high, they are will be enabled, otherwise they will be disabled. And this D in is the input signal and D out is the output signal. So we are applying a 1. Okay, so we are going to write a 1. So we want to store a 1 here. So what we will do, we'll apply a high signal at the input data because we want to write the 1. Then the read signal is kept low. This is kept low, so it means we are going to perform the write operation. So this is low, and this low is connected here 0, and here what is this inverter is there, so the output of this inverter will be 1. It means the 1 will be applied to this inverter, sorry, buffer, and the buffer will be enabled. So this input buffer will be enabled. So the whatever the data high is applied, so high is here and high will be available here. Okay, so buffer transfers same data, is not inverter, it's whatever the data is at input, they will transfer at the output. The only thing is that they are used for the impedance transfer. Okay, to avoid the loading effect, you might have studied somewhere. So this one is here. So now you can see that this voltage is high and this line is connected to this column line. This is also called as a bit line. Okay, so this is connected to this point. Initially, suppose the capacitor was discharged. So what will happen? This will these two will be connected and the capacitor will start charging. Okay, and the capacitor will continue to charge till it becomes 1. So there is a prescribed timetable for reading and the writing. You already know the timing diagrams from the microprocessor, so that according to that timing diagram, it will take the sufficient time to charge and the capacitor will be charged to a high value. So this is how we can write a 1. The third thing is writing a 0. So what will happen? 0 means if there is a charge on the capacitor, we want to discharge the capacitor. If it's already 0, then nothing will happen. But if it is already in one state, so it will discharge to the low state. Again, we are doing a write operation. So with this signal will be low. So this is low. So this will be this buffer input buffer will be enabled. So okay, so we want to write a 0. So we will apply a low signal here at the input side. So what will happen, since this is low and this is also low, okay, so what will happen, the capacitor, if the capacitor was charged to 1, the capacitor will start discharging through the circuit. Okay, the capacitor will start discharging. Okay, so the capacitor will start discharging to this bit line. So this is how once the capacitor is discharged, so we can say that the discharging is finished and the voltage the 0 bit is stored in the capacitor. So this is called as the this process is also called as the writing. So now the 0 will be stored at the capacitor. The third operation is the reading a 1 from the cell. Okay, and now we want to read. Okay, so reading 0 is same to the 1. Suppose the 1 was stored here. So now we are, first of all, the signal that we are going to apply is the read and write signal to be high. So it's because we are going to perform the read signal, so the R should be high. So since this is the high, so the output of this inverter will be low and this transistor, this buffer will be off. So the high signal is enabled. So this signal will be, this buffer will be enabled here. Okay, so this buffer, output buffer will be enabled. Okay, so high is here. And remember, this row signal is always kept high. As I told you, whenever you want to access perform any operation, this row signal is to be kept high. So this capacitor is high voltage is there, so this will connect to these 2 points, and these 2 points will be connected. And what will happen? So this is high, so this will become 1, and this is high, so this is high. Okay, so we came to know that the bit stored was 1. Okay, this bit stored was 1. And remember that we are keeping this refresh signal as low. While the read and write operation, both the case, we keep this refresh signal as low. Refresh signal is kept high when we want to do the refreshing. So this is how we can read the stored signal. The last operation is the refreshing a stored one. So what we do here, that we apply a refreshing is like writing, sorry, the reading operation. So what we'll do, apply high, so this is gone. ओके, सो दिस इज गॉन. सो हमें वन को ही रिफ्रेश करना पड़ता है, मैंने आपको पहले ही बताया. सो वन, इफ दिस वन इज हाई, so this will connect these 2 points. Okay, remember this row is high, and now the refresh is also high, so this is buffer is also enabled. Okay, this buffer you can see is connected to the output of this previous buffer. So high is here, so it means high will be here, and this high will be available here as well. So what it will do, it will start charging the capacitor again. So okay, so it will be like a cycle, and this will start refreshing the charge on the capacitor. So this is how the charge of the capacitor is refreshed. Okay, so this all are the operations for the capacitor DRAM cell. DRAM ऑर्गेनाइजेशन यहाँ पर नीचे बनाया है, अब मैंने उसको उस लेवल से बाहर रखा है. ठीक है, बट द DRAM ऑर्गेनाइजेशन, लाइक वी टॉक अबाउट द पैकिंग डेंसिटी, मैंने आपको पहले ही बता दिया कि DRAM की पैकिंग डेंसिटी एज कम्पेयर टू SRAM ज़्यादा होती है. यही दोनों में एक मेन डिफरेंस भी है, हालांकि दोनों में सिमिलरिटी है कि दोनों वोलेटाइल होती हैं. ओके, तो कैपेसिटी ज़्यादा, पैकिंग डेंसिटी ज़्यादा, बट ऑल्दो मच स्लोअर एक्सेस टाइम. तो DRAM का बस एक थोड़ा ड्रॉबैक ये भी है कि थोड़ा एक्सेस टाइम स्लो होता है DRAM का. ये ओके, सो अनदर थिंग, जो बात ये थी कि कैपेसिटर चार्ज विल लीक आउट, सो द DRAM cell requires a frequent refresh operation of to preserve the stored charge. तो हमें बार बार रिफ्रेशिंग ऑपरेशन करना पड़ता है. ये भी एक टाइम किलिंग ऑपरेशन है, देखा जाए तो एक तरीके से. ठीक है, so the next thing is the reading and the writing diagram. So I'm not going to explain. I know, I think that you will be knowing those things from the microprocessor. So if there is any problem, you can ask me. So from my side, this is the end of the syllabus. If you need any help, you can contact.